Hello everyone, my name is Kristen Kroom, and this is my oral presentation for my nuclear capstone class at Thomas Edison University. My group for our final project consisted of Will, Dan, and I. Our paper is called The Fukushima Daiichi Accident, the Fall of Nuclear Power in Japan and Beyond. On March 11, 2011, a chain of unimaginable events occurred that devastated not only the country of Japan, but the rest of the world as well. This accident brought the nuclear industry in Japan to a grinding halt. As a group, Will, Dan, and I decided to split our research paper into parts. We used our outline to divide the topics among the three of us. Our paper is called The Fukushima Daiichi Accident, the Fall of Nuclear Power in Japan and Beyond. During this oral presentation, I'm going to be discussing my part in the research paper. I have three topics that I would like to discuss. First, I will be discussing the nuclear industry in Japan before the accident in 2011. Then I will be discussing the location of Fukushima. After that, I will go into an overview of the design of the Fukushima plant, starting with the reactors and the cooling system, and then finally into the containment itself. After I'm done with my oral presentation, Will and Dan will continue with theirs to discuss the accident and how the accident affected the population of Japan and the nuclear power industry. The beginning of nuclear power in Japan. Japan is a highly industrial and populated country, but it has to import 84% of its means for producing energy from other countries. They must import things like oil for fuel and energy purposes. As a search for a better way of producing energy began, Japan was still recovering from the fallout of the atomic bombs that destroyed Hiroshima and Nagasaki. As you can imagine, the opinion of the Japanese people was not very high in regards to nuclear power. They had seen what the radiation could do to people firsthand. But since the demand for energy was so high, they began a plan for construction of a nuclear reactor. In 1955, the Atomic Energy Basic Law was passed. It stated that nuclear technology could only be used for peaceful purposes, such as energy production. A budget was then formed for 230 million yen that was to be put towards the construction and operation of nuclear power plants. Japan, at this point, had cautiously embraced the use of nuclear technology for their energy needs. The first reactor in Japan began operation in 1966. Takai was a reactor that was built by the United Kingdom's General Electric Company. The reactor had a total output of 166 megawatts. Takai was a Magnox reactor that was fueled by uranium and was cooled by carbon dioxide. Because the demand for energy was so high in Japan, the 166 megawatt reactor was not going to be enough. In the 1970s, the Japanese began to buy parts and plans from the United States. In the years to come, Japanese contractors were licensed to construct reactors without help from outside countries. Before the Fukushima accident, Japan had a total of 54 reactors in operation, but that only supplied 30% of the energy needs that the country consumed. The Fukushima Daiichi plant is located in Akuma in the Futaba district in Fukushima's prefecture in Japan. The power plant site covers a 3.5 kilometer area. The location sits on the edge of the North Pacific Ocean in an area known as the Ring of Fire. This area is called this because it is known for having some of the largest earthquakes in the world. The land area is covered by mountains and volcanoes. Even with all the natural disasters surrounding Akuma, the population before 2011 was around 200,000 residents. This population has since decreased dramatically because of the accident at Fukushima. The Fukushima Daiichi power plant consists of 6 reactors. All the reactors are BWR reactors. BWR stands for boiling water reactors. This means the reactor core produces heat through nuclear fission. This heat is applied to water in the reactor vessel, causing it to turn to steam. The steam then travels through piping to the turbine blades. As the blades spin, the turbine generator produces electricity. The steam is then cooled in the condenser and pumped back through the loop to start the process over again. With all 6 reactors in operation at the Fukushima plant, the total energy output would equal 4.7 gigawatts. There are several ways to remove heat from the reactor core while shut down. The first is the residual heat removal system. This system operates off of diesel generator power. The system uses smaller pumps to circulate water through the reactor pressure vessel, removing heat and transferring it to the residual heat removal heat exchangers. The heat is then dumped into the sea. The next is the isolation condenser. Unit 1 of Fukushima has an isolation condenser which is operated by DC power. The isolation condenser system directs reactor steam to an external condenser in order to cool the reactor core. Finally, there is a reactor core isolation cooling system. Units 2 through 5 in the Fukushima plant have this system. The reactor core isolation cooling system is put into operation automatically, but is powered by the DC battery system. The system provides makeup water to the reactor pressure vessel from either the condensate storage tank or the suppression pool to ensure that the reactor core is covered by coolant and the heat is removed. The emergency core cooling system is backup for a loss of coolant casualty. It consists of 2 elements, the high pressure coolant injection system and the low pressure coolant injection system. The high pressure coolant injection system draws water from the suppression chamber under the reactor and the water storage tank, using pumps that are powered by the steam turbines. This system is able to operate over wide pressure ranges and requires only DC battery power. The low pressure coolant injection system operates through the residual heat removal system, but draws water from the suppression pool and uses a core spray system. The core spray system is exactly that, a system that sprays water directly onto the fuel rods to remove heat. The boiling water reactor Mark I containment is a dry well made of 30mm steel that is reinforced with a concrete shell. The shape of this containment is bulb-shaped. This dry well contains the reactor pressure vessel. Under the dry well containment is a torus-shaped wet well that contains a suppression pool. The dry well and wet well are connected by a system of vents. The function of the primary containment is to contain the energy in the event of a loss of coolant casualty. This containment is also protects the reactor from any outside assault. Thank you for watching my oral presentation for our nuclear capstone class at Thomas Edison University. This is just an overview for the research that I have done and what I have written in our paper called The Fukushima Daiichi Accident, the Fall of Nuclear Power in Japan and Beyond. Now Will and Dan will continue to discuss the accident and the effects that it had on the nuclear power industry. Thank you.